Hey, what's up, physical science? This video is going to teach you about the metric system. Metric system, I know you've learned it before. We're going to be using it all year, so it's important that you really understand how it works. So the metric system is composed of a couple of key ideas. First of all, we have what are called base units. Base units depend on what we're measuring. If you're going to measure the length of an object, let me just make this a pen, you are going to use a base unit called the meter. So anytime you're measuring distance or length, the meter is your unit. If you are measuring the volume, we use liter. And volume, I mean the space something takes up. I'm not talking about loudness. And if you want to measure the weight of an object or the mass, how much matter is in it, we generally use a unit called the gram. There are other base units, but those are the three that you're going to see the most. We can modify those base units by adding prefixes. And we'll get into all the prefixes later in this video, but first you can see a couple of examples. The centi is a prefix that we use. We can add it to any of our base units. Here we've added it to meter to make what's called the centimeter, or cm for short. Another prefix that we can use is kilo. Kilo we can add to gram to make the kilogram, or kg. So prefixes plus our base units create the units that we use in the metric system. So here are a review of the three base units. The meter, which is abbreviated M, is used for measuring distance and length. The measuring tool we would use for that, of course, is the ruler or the meter stick or a measuring tape, something that measures the distance from two different points. For mass, we use grams, which is abbreviated G. Mass is defined as how much matter is in something. And so we use a balance, like a triple beam balance or maybe a digital balance. A scale, like a bathroom scale, will also give you the mass, or sometimes we call that weight, of an object. And the third base unit you're going to see a lot is the liter. The liter is used for measuring volume, which is how much space an object takes up. The measuring tool varies depending on what we're measuring, but for liquid volume and for volume of irregular solids, we use what's called a graduated cylinder. So, for example, if you want to measure the length of something, how wide something is, or how tall something is, or the distance from point A to point B, you would use a meter. So here's some examples. A tree branch, an average length of a tree branch, I guess, is about 1.5 meters. The length of a room, typical like the science room that you're sitting in, or maybe you're not sitting in the room right now, but I don't know, is about 5 meters. So 5 meters corresponds to roughly 15 feet, if that helps you kind of figure it out. And a length of a ball of twine is 25 meters, so there you go. So what if you want to measure something much farther, like the distance from your home to Monarch High School? So let's say you live 10 miles away. Well, 10 miles is a lot of meters. It's 16,093 meters to be exact. And 16,093 is a big number. It's kind of hard to say, and it would be really irritating if you had to deal with that number all the time. So what we do is we modify meters with a prefix. So we can modify that with kilo, as we can see down here. And we can see that 16,093 meters is equal to 16 and just a little bit extra, 0.093 kilometers or kilometers. You could round that to 16.1, and it's a much smaller number. So what we've done, we've made our unit larger by adding kilo to it to make the number smaller and more manageable for us. Okay, we'll see some more examples of that in a little bit. So here are the common prefixes that we use in the metric system. We have kilo over here, we have hecto, we have deca. These are the base units. They do not have prefixes in front of them here in this little chart. We have what's called deci, centi, and milli. And a few of these you may not be that familiar with. A couple of them you probably are. I'm sure you've heard of a centimeter. I'm sure you've heard of a kilogram. But some of them are a little bit different, like hecto, we don't really use a whole lot. They are arranged in a particular way on this table, and this is where we get into why the metric system actually makes sense. Before we get to that, though, real quick, the prefixes have their own abbreviations, and generally we use just the first letter of the prefix, which makes it pretty easy. So kilo is K. We use a capital letter for kilo, hecto, and deca. These are the ones to the left of our base units here. And then deci, centi, and milli, we use lowercase d, lowercase c, lowercase m. One word of caution, milli is abbreviated m. You might remember that the meter is also abbreviated m. So here we have two things that have the same abbreviation, which causes great distress for a lot of students. Deal with it. So metric system, yeah, here's some more examples of how we're combining the prefix with the base unit. We have kilograms, or kgs, centimeters, or cms, deciliters, or dls. This is just the gram, so the gram here is just G. You don't always have to put a prefix in front of your base unit. Sometimes grams is just fine. We don't use a prefix there since it is just the base unit. So although prefixes, all of them are important and you need to know hecto, deca, deci, all of them, there are a few that you see much more commonly, and that's milli, centi, and kilo. Milli is defined as 1/1000th of a base unit, the centi is 1/100th of a base unit, and the kilo is 1000 of a base unit. So for example, if you had a kilometer, that's equal to 1,000 meters. A kilogram is 1,000 grams. So here's just a reminder, keep in mind you don't have to use the prefix. Sometimes meters is perfectly appropriate, but sometimes we want to modify it. If we're measuring something really small, we would use millimeters or centimeters. Measuring something big, we would modify it by using kilometers instead of just meters. Hope this is making sense so far. So the prefixes, as you notice, had lots of ones and zeros in them, and that's because they're arranged on powers of 10. So what does this mean? Well, it means for every prefix is either 10 times bigger or 10 times smaller than the one next to it. So for example here, it says centimeters are 10 times larger than millimeters. So here's centimeters, and here's millimeters, okay? Or it could be centigrams or milligrams. It doesn't matter what the base unit is. The prefixes don't change. The millimeter, we'll use that as our example, is 10 times smaller than the centimeter. So when we go this direction, we're going bigger. So there are 10 millimeters in 1 centimeter. That's because the centimeter is a larger unit. If we go one more step over, for centi to deci, we see the same thing. So it's 10, see if I can draw the number 10 here, 10 times bigger, going this way, and then we go 10 more times bigger to go from centi to deci. So what that means is that there are 10 millimeters in 1 centimeter, there are 10 centimeters in 1 deciliter, and you can see it goes the same way. So there's 10 decimeters in 1 meter, 10, 10, 10. So the metric system, the most important number to remember is 10. So for each step to the right, you're going to multiply by 10. Okay, so to go from centi to milli, so if we're going to go the other direction, 1 centimeter is equal to 10 millimeters. So we've taken 1 times 10 to get us the number 10. So 1 centimeter is equal to 10 millimeters. Okay, so what if you want to go 2 steps? What if I have my measurement in deciliters and I want to convert it to milliliters? Well, having some trouble with the arrows here. There we go. We need to multiply it by 10 twice. So 10 deciliters is 10 centimeters is 100 milliliters. That's 10 times 10. So here's some examples. So 1 liter, starting here with our base unit, is equal to 10 deciliters, right? Because we've gone 1 step to the right, so there's 10 of them. And then another step would be 100 centiliters. So you can see 1 times 10 is 10, 10 times 10 is 100. So to go 2 steps over from the liter to the centiliter is going to be 2 steps. So that's going to be multiplying times 10 twice. What if you had 2 grams of something? Well, gram is the base unit right here. And so 2 times 10 would give me 20 decigrams, moving 1 to the right, and then 200 centigrams. So you start with our original unit, multiply by 10, multiply by 10 again. If we want to go to milligrams, we just multiply by 10 again. To 200 times 10 would be 2,000 milligrams. Okay, and so because it's based on the number 10, it makes the math a lot easier. To multiply by 10, we just add a 0 to the end. To divide by 10, if we were going the other direction, we would just move the decimal over. And we're going to learn in a future video a shortcut for making these conversions within the metric system where you don't even have to use your calculator. So here's our review. To summarize, the base units in the metric system are the meter, the liter, and the gram. Do you remember what each one is used to measure? Base units are modified by adding prefixes to make them bigger or smaller. The metric system is based on powers of 10. For conversions within the metric system, each step is 10 times bigger or 10 times smaller than its neighbor. And the most commonly used prefixes are kilo, centi, and milli. But keep in mind, we don't have to use a prefix every time. Sometimes we can just use meters, liters, and grams by themselves. We don't always have to change it. So I hope that gave you a good introduction to the metric system. If you have any questions, we will review this in class at the beginning of class tomorrow. And make sure you raise your hand and ask lots of questions, because this is a really important concept that you're going to be using all year long.